this video, we're going to look closer at why something raised to the power of 0 is just 1. It's kind of weird. I'm assuming that you already know that if something has an exponent of 0, it's just going to be equal to 1, but you might not know why that's the case. So that's what we're going to do today. Evidence-wise, we're going to examine powers with positive exponents. We actually have to look at some other types of problems before we can look at the 0, because we're going to need to find a pattern which will help us explain why a number with an exponent of 0 is just 1. We might even take a sneak peek at negative exponents, though that would be a video for a different time. We got some learning experiences down there. We got some suggested practice problems at the end. Amazing. All right, so we have this table. I would suggest copying it down to your paper if you have some. And what we're going to do is we are going to start off by just looking at these 4 expressions. We're going to start off by writing them in expanded form. So this is going to be 2 times 2 times 2 times 2. If we actually calculate that, we're going to end up with 16. Nothing too bad so far. Next, let's look at 2 cubed. That's going to be 2 times 2 times 2. That's going to be equal to 8. 2 times 2 is 2 squared, so 4. And 2 to the first is kind of a weird one. We're just going to have 1 2, a single 2, which is obviously just equal to 2. So that's what we need to get started with this. Now, if we look carefully, we'll see a few different patterns in each of these columns. If we look at this column, this first one, we'll see that each time we go down the column, our exponent decreases by 1. That continues down with 0 and even -1 and -2. So we have a bit of a pattern there, but we know that that's going to happen. That's not going to change anything. If we look at the next column, we see that because we are writing this in expanded form, here we have 1, 2, 3, 4 2's. Here we have 1, 2, 3 2's, 2 2's, and then a single 2. So each time we're doing this, we're losing a 2. Now, it'd be very tempted to say, well, if we do that, surely we should end up with a 0 here since we don't have any 2's anymore. And you might take that guess. That's not an unreasonable guess. Before we make that guess, though, let's look at our last column as well. We go from 16 to 8 to 4 to 2. You might be wondering, what is the pattern here? We could maybe try subtracting by 8, but then if we do that every single time, 8 minus 4, it definitely does not equal 4. So we can't do that. Can't use subtraction here. There's another pattern that we could use. Well, maybe we could divide by 2. So if we divide 16 by 2, we get 8. Let's see if it works again. 8 divided by 2 is 4. Cool. 4 divided by 2 is 2. Okay. So this pattern seems to be working. And going back to this middle column, we earlier said it looks like we're taking away a 2, which is true, but in this case we're not subtracting, we're actually dividing. So each time we divide, we lose a 2. And if we continue this pattern, if we divide this by 2 again, 2 divided by 2 is just going to give us 1. Now, as for writing this in expanded form, you can't really because there aren't any 2's to write. So we could just write this as a 1 over here as well. Hopefully that clarifies a little bit as to why any number to the 0th power becomes 1. You could make the same chart with any number as your base. It genuinely doesn't matter, and you'd get the same result. If you make your base 3, if you make your base 15, if you make your base 10,000, you could use a variable for your base. You could use x as a base. Anything you do, if you follow this pattern, your numbers in this expanded form might be different. Your numbers in the Evaluated version might be different. You'll also have to divide by a different base. You'll notice our base and our number that we're dividing by match here. But if you do those things, you'll still end up getting 1 when you raise it to 0 power. Now we could continue that pattern. If we divide 1 by 2, that's going to give us 1/2. If we divide 1/2 by 2, that's going to give us 1/4. And I'm not going to go any further than that, but I'm willing to bet if you kept going, you'd start seeing another pattern. And there is something that you can actually do with your expanded form here as well. I'm not going to go into great detail with it, but I imagine, looking at that, you'll be able to figure out what the pattern is and what a negative exponent actually does to a base. Things to remember about this, really the key thing is just to remember that anything with an exponent of 0 is going to be 1. It genuinely does not matter what your base is. If the exponent is 0, it's going to be equivalent to 1. We prove this by analyzing the pattern of our exponent changing, decreasing by 1 each time until we got to 0. We kept our bases the same. Again, you could try it with any base and this would still work. In fact, I would encourage you to try it. We're going to end the video by looking at some suggested practice problems. You have some things to evaluate. They all have a exponent of 0. Clearly, this is going to be very hard. After you finish it, since this is a short video, make sure to hit like and subscribe and all those other YouTube things. Yeah, good luck.